Hey, Dr. Stansel, it's Ashley. It's 2 days later now, so week 6. This is video 2. This is on our environmental influences on microbes in both salt solutions and their pH. So I did wait the full 48 hours for them to incubate, and I'm going to show you the results. Just a reminder, we did salt and pH. So what I'm going to show you first is the salt, our tubes, our test tubes with the results, and talk about those. So let me face the camera down, get some of these over here for us. All right, so let me show you. So here is our S cerevisiae. This is 1% salt, okay? So see if you can kind of see it. You can see there's turbidity in there, or cloudiness, okay? So remember, S. cerevisiae is usually in acidic solutions on fruit, as our lab assist mentioned. It's a little cloudy, okay? So 1%. So I'm not going to say that one's negative, actually, which surprised me. Now, here's S. cerevisiae in 7% sodium, and it's pretty clear. Do you see it? Pretty clear. So I'm going to say that's a big fat negative. And then here's S. cerevisiae, and that's also clear in the 15% sodium. Let's even just compare 15% with the 7%, both pretty clear, right? Okay, so let's look at S. epidermidis, which is naturally on our skin, right? So here's the 1% salt again, and you see it. It's cloudy. It's turbidity. You can see it, and I wish my camera was a little more clear because you can actually see a layer on the top there. All right, and here is S. epidermidis, excuse me, 7% sodium. Now you can't see this very well. It's fairly clear. I would say there's a small layer down here, if you can see it, and some bubbles. All right, but I'm still gonna call it negative. I don't see much in comparison. And then here is S. epidermidis at 15% salt, salty environment, osmolarity, I should say. In this case, it's salty solution, but it's osmolarity. This is also a negative, right? So most microorganisms, when they grow in a salty solution, they prefer isotonic, which means equal amount of salt and the solute and the solution. So again, now I'm going to show you all of these up close. I'm going to lay them out since the camera's facing that way, and I'll do a close-up. Maybe that's not smart. Let's try it out. We'll do a close-up of these guys, and I'll show you again. Yeah, it's not very effective. That the 1% on each one are the most cloudy, and you can see the other ones are clear. Okay, so there's our osmolarity, our salt solution. 1% on each, both S. epidermidis and S. cerevisiae, I'm going to say are positive and the rest are negative. Now, our pH. Now, most microorganisms are neutrophiles. In other words, they grow best in a pH of around 7, right? So this one, here's S. epidermidis, and this is a pH of 5. Slightly, okay? Here's S. epidermidis of 7, little slight. And here's S. epidermidis of 9, just a tad more. But you can see the comparison when I hold them all together, that 9 has a little more cloudiness than 5 and 7, right? Don't know if you could see it in the light. Maybe I need better light. Okay. So, and then last but not least, S. cerevisiae, pH of 5. There's cloudiness in there. See the cloudiness? And a pH, remember 5 is acidic. And pH, little cloudiness as well. of 7, and the pH of 9, also a little cloudiness. But I would say S. cerevisiae, cloudiness of S. cerevisiae, pH of 5 has the most turbidity in there, and S. cerevisiae, remember, grows on fruit, and here it is in acidic environment, which when it's this extreme, it probably is an acidophile, right? Acidophile versus being neutral and alkophile. So those are my results. Thank you, Dr. Stansel. I will post my pictures.